Good afternoon, ladies and gentlemen. My name is Rusty Berg. I'm coming to you from here somewhere in southeastern Michigan. Welcome back to the Antique Automotive Acres. Thanks for stopping by. We're back on the last wheel I have to take apart for Eleanor, my 1914 Studebaker. If you haven't gone through the little bit of the saga I've put together here, this whole project is being started from the fact that I had a spindle snap which damaged one of the wheels, and I am getting them prepped to take down to an Amish Wheelwright to get them reassembled, given that the one took some significant damage, and if I'm going to fix one, I might as well fix them all. What we have here is the last wheel, which is actually the rear passenger side wheel of the car. It's the driving wheel, so it's different than the front wheel that we previously took apart, and because of the way it's set up, it actually has some more unique challenges associated with taking it apart. As you can see, I've already removed the rubber tire portion of it. That's the same as any of the other wheels are, so no need to go through that process again on camera. It's the same thing. Take the lug nuts off, pull the rim off. The tire is currently sitting off camera, waiting for when the wheels will be back and ready to go back together again. So with that, we've got one more wheel to bust apart. This one is going to take a fair amount of work to do from what I have learned. So why don't we go ahead and get things started. So I broke the handheld camera out again just to give you guys an overview of what makes this wheel different than the front wheel that we previously took apart. And really where it all centers about is this hub right here. This is the, again, what I mentioned, this carries the bearing races for the outside bearings that support the weight of the vehicle. It's what makes this a full floating rear axle. So if you can see right here, that's one of the bearing races right there that the Timken roller bearing rides within. And it's actually a standard part number. You can still get, I believe it's this size from Timken, readily available, brandly new made. But I hinted at the top of the video that there is some unique features about the design of this rear wheel that is going to make it very challenging to get this taken apart in a quick and easy fashion. And it starts with these 6 studs right here. These, if you remember from when I took the axle out, are what is actually driving the car forward. So they have this little step shoulder. You'll see a lot of RTV on here. I use it as sort of a sealant to hold it together. But you'll see this step shoulder here, right at the tip of my finger. That's where the flange interfaces to drive the wheel forward. That's really not a hard part about taking this apart. They are awkward because these are unique to Studebaker or any sort of floating rear wheel design like the full floating rear axle design like this. It's going to be a part that the Wheelwright won't have in his stash of parts when it comes time to put these wheels back together again. These threaded parts do go all the way through the drum. This is the drum brake right here that is used to stop the car. They go all the way through and are what are clamping the hub to the drum, which acts as the backing plate for the wheel. What really is going to be a problem, and I'll show you when I flip this over, is these guys right here. These are big flat head machine screws, which I don't know why Studebaker used them. They're I can't call up the company and ask them what they were thinking. They've been gone since 1966. So anybody who might have an idea as to why they would use this, other than they are flush to the wheel itself, feel free to drop a comment down there below in the chat window. Maybe I'll learn something. But these are impossible to take apart easily, because as anybody who's ever used a flathead screw knows, the bit likes to jump out of the slot, and when that happens, you mar up the surface, and then the bit won't ever engage again. You can't actually twist it right. So Let me flip the wheel over real quick and show you why this is going to be a problem. Okay, so I flipped the wheel over and applied a little bit of yellow paint to the backside to indicate which one of these nuts is on those machine screws. And what you can see is that at the factory, these were peened and ground within an inch of their life to essentially lock the threads in place. You don't want these falling apart, which is okay usually. You don't, I'm fine with peening them. That's what holds this wheel together, keeps it from falling apart. The problem is coming to take them apart. Now, on the other nuts that aren't marked with a paint mark, like this fella right here, these are the driving studs, those shouldered bolts. Actually, I can show you what one looks like. I had to go ahead and machine a couple of them here. I'm carrying you at a bad angle. Give me a second. There we go. So this is what one of those studs looks like in brand new fashion. A little bit of a machining project. Sorry I did this off camera. I just didn't have the time to run the camera and run the lathe concurrently, but what you can see is there's the metal shoulder here. That's what drives the flange. And then there's this lovely square shoulder here. That's what locks the bolt into the, or the stud into the hub. You can kind of see on the other hub that's been taken apart here. That prevents us from rotating, which is nice, because then on the back side of these, with the nut that's been peened over, you can just hit it with a very large wrench and be confident that this is not going to spin on you while you're trying to take it apart. No such luck on the machine screws. They're just a round machined pocket like you would for any machine screw. So the problem is, back to our candidate wheel that's being taken apart, is that, as I pan you in, for me to hold the backside of this with a screwdriver and try to impact this off is near impossible. And yes, I do have impact screwdrivers, the type you hit with a hammer, that are supposed to be able to help break these things free. I did try that. It did not go well. Unfortunately, the bits tend to break when there's no movement. And to be honest, I went through a couple bits on my impact screwdriver. So we're going to have to get creative here to get these apart. Now, there's a couple options I have in the shop to do this. The first one I did, I went a little bit of the old school gas axe route. Yeah, that's right, I hate doing it, but sometimes you just can't beat the power of oxyacetylene. I went through and used the tip here to torch the threads out of the nuts. So I literally went in and just kind of torched the center portion here and cut it through. That I have to be very careful with, though, because right now this metal piece is right behind it, will also be heated, and there's a natural tendency that maybe that cutting torch would cut into the drum surface itself. Not ideal. So for the next version of how we're going to try to do this, we're going to go to a machine that you haven't seen me use in the shop quite yet. You've seen it sitting in the corner. We're going to take these, we're going to try and jig this up in that mill over there. I've got to set it up to do this, but we're going to jig the wheel, this particular wheel, up and come in and plunge cut these threaded parts out of here until I can knock the nut free and thus finish taking apart this wheel. So these are the driving studs. These I can take off with an impact, so I'll show you that process coming up right now. All right then, I've got the camera set back up. I'm usually not a fan, again, of doing impact tools on these early type of cars. With the early metallurgy, typically what's going to end up happening is, unfortunately, the threads are going to rip off. But at this point, there's not a whole lot I can do. I need to get these taken apart. So you'll notice I had a whole bunch of new driving studs made, because when I learned how to take the last one of these wheels apart, each and every one of the threads ripped clean off, rendering them useless. And that's not a part the wheelwright is going to have in his arsenal of parts for putting wheels together. Therefore, I had to make them up. So I'm comfortable in at least bucking the, or using the air impact on the 6 bolts, 6 nuts that have the driving studs behind them, and then, like I kind of hinted at, we're going to have to do some more creative machining work to actually get the last 6 studs out of this wheel so that we can go ahead and get this taken apart. So I need to go put in a set of earplugs. I've got my safety glasses on. As somebody who's already got slightly reduced hearing capacity, this is going to be loud. So let me pause that. We'll be right back with earplugs hooked up, ready to take this thing apart, or at least get started. Okay, I've got hearing protection engaged, just because, again, you see it a lot of times in older machinists and even older folks who have wrenched on cars before. They start suffering from hearing loss, or even more bad things that can happen, things like tinnitus, which is a constant ringing in the ears. A little bit of protection in the form of these just orange foam expandable plugs can help knock the tone of the noise down a bit, protect your ears. So now let's get to wrenching. That's one. I'm going to let that cool off. It's a little bit warm. Now, some of these have a little bit of a damaged edge to them. It's unfortunate, but I think the problem is that they got peened over a little too hard. So I need to get the socket set on the nut, just so I can even get the air gun installed and wrenching. Aha! That one ripped the threads clean off, but did come apart. So, now I just got to see about removing the other nuts that came off, which you can even see here. This is why I don't really like using impact tools. You can see that the thread is left in the nut. This metal isn't hard enough for really impact work, but you got to do what you got to do. So I've got to continue working on this and see about removing some of these are off, but they're stuck on torn threads. I got to work on getting the last of these pieces apart, and then we'll go ahead and get set up over on the mill to go ahead and finish the rest of this job. So let me do a little bit of cleanup work, and then we'll move over to the mill. Okay, I've moved the camera on its tripod over to a different section of the shop here. Not one that you might have seen me done in a video before, but this is my milling machine. It's a Jet and or Bridgeport Knock-off. There's a long story of how I acquired this device, however, not really as interesting as the handy lathe that is currently over my shoulder. Right now it was set up, what you see here is the setup I was using to making the square flats for those driving studs, which I had to replace, since, as you saw in the video, previous clip, where all the nuts essentially ripped the threads right off of it. So now I've got to jig this table up to essentially hold the wheel in place, and then we'll come in with the quill and an appropriate sized end mill to essentially plunge cut out, come down and essentially cut the material out that's locking that nut in place, and allow me to take the rest of the piece apart so that the wheel can be finally disassembled. So we're going to go into a bit of time lapse as I scratch my head about 16 different times and figure out how to fit the wheel on the table here. So let's go ahead and get them started. Ooh, that actually sits pretty nicely. problem I am going to run into is depth of travel. Okay, I can, I have to raise the table up a bunch. Not setting flat. Okay, we're gonna have to set you up on blocks. Okay, blocks. Unlock. A couple more of these 1, 2, 3 blocks. A couple more 1, 2, 3 blocks acquired. If you don't know why they're called 1, 2, 3, they're 1 inch by 2 inches by 3 inches. So come in handy for different jigging and setting up, and even just putting, you know, holding stuff up an inch off the table, because one of the studs is sticking through still and is giving me problems that I can't keep the wheel flat. So let's bring this down. I'm just sliding these under the flat surface of the hub. The intention being to give me a relatively stable spot that I can, because some of the driving studs are still in there, they're interfering with the table, not allowing me to get the wheel to sit flat and flush. So these will help allow me to line things up and do that. And then we just have to find a way to clamp it down, which I think what I'll end up doing is, yeah, I like that. I'll just come right in here and clamp it down in the center with a big T-bar. That'll work nice. That's sitting relatively flat. And now, part of my problem is actually going to be getting clearance to drill this, which I think will end up, what we'll end up having to do is clamp and then rotate, clamp and rotate, and then we can use the axis control to give me a fine sort of adjustment to the location to come in and plunge out the material. That's the working plan anyway. Okay, I need to get a clamp bar across this, so I need to go over here and get a T-nut and one of my long studs. Okay. Acrobatics. I don't know if that's going to be long enough. We'll find out. Let's find out, shall we? Okay. I'll step down here. Easy peasy, lemon squeezy. Oh yeah, that's going to be plenty long. So what we'll need to do, take the wheel back off again. Slide this up the ways. Let me hold the wheel. Second here. Okay. That's good enough. Slide that. Oop, maybe. Come on. Up you go. There we go. Come along. And we go. Let's drop this down a little bit just so I have some room to get the wheel over. And then we can raise it back up once it's all clamped into out position. Clunk. Didn't want to do that. That's how you break stuff. There we go. Okay, now I need to get you to sit. Why aren't you sitting? Down there. Down, down, down. Come on. What are you hitting? You're hitting something. Why aren't you sitting? Okay. Yes. Oh, it's hitting the back of the, there we go. So, can I get, see the problem now? Okay. I need, I'm gonna have to extend the head out a bit because I can't move the table back anymore. Problem is right now, the quill, the center of the bit, is without being able to really move the table once this is clamped down. I can get fine movement. In fact, I need to build some fine movement into it. I can move it back some and clamp it down, but the head center line is not going to allow me. I can bring it back a little bit for fine movement, but I've got a gross misalignment here of where I need to be to actually get in and plunge it. So these mills have a setting, well, it's really just a control where you can extend the arm out a little bit. The control's over on the other side, so I have to carefully step around the camera, unlock the head, and bring it out some. So let's see if I can do that without bouncing the camera around. Like I said, carefully, carefully, step, step, step. I might not be on camera, but I am coming in. So these are the adjustments I was talking about. And there we go. We can extend, and I'd go a little bit further. That way I can pull the table towards me, gives me enough, and I've got relatively good support on the head, because the problem is the more you do this, the tendency when it comes to precision machining is that it's going to want to dip down just because of the extension arm. But we're not really going for precision machining. I'm not certain you can see me, but this will allow me enough room to come in and, like I said, plunge down and cut that material out. So need to lock that in place and lock that in place so it doesn't go anywhere. And now step out. Okay, hearing protection installed again. Just want to save my ears for later. We have it lined up. A little bit of sauce, oil on there just to help the flutes as they start cutting in that material. I've got the machine set about 1,000 RPM. We'll see how it sounds as I start cutting. So only one thing to do now. Let's give it a go. What I was afraid of is these starting to rotate. So shut it off, bring that up. So the nut started spinning while I was cutting, and you could see the whole thing jump because of it, because it caught. So what I need to do is actually tighten my clamp down a little bit more. And I'm just clamping on the hub itself, so there's really, I can give it a fair amount of welly to hold it together here. So we'll give it a little bit more and take a look-see here. Coming around. Let's do it. I'm gonna stop. So I'm slightly above the height of the surface of the drum itself. So now what I need to do is see if I can get a cold chisel in there and a hammer and smack it out. So let me go see about finding said cold chisel and hammer. Cold chisel and hammer. Let's just, fries are done. Let's just see about breaking that off. Hey! I don't know if you saw it. It went flying through the air with the greatest of ease. So that's one down. We have 1, 2, 3, 4, 5, 6, 7 left to go. So let's, next step is to rotate the wheel, loosen the stop up here. This down like such. Ding! Fries are done. I know some folks say that already, but it's still funny. All right, we're going to lock that in place for a second so I can give myself some better idea of alignment. Come over here, jog it around, jog it back, quill up and out of the way, slather on some oil and/or sauce. Sauce it up good and engage. That's enough to break it free. That might be enough to break it free because this is a smaller nut. So we come back with the precision adjustment device and the cold chisel. Ha-ha! Success. All right, I've got 1, 2, 3, 4, 5, 6 more to go. I'm going to continue what you've seen me do, which is to loosen that up, spin it, line it up, and start hunting and pecking. So I'll bring it back around when we come up for the last one, maybe bring you in so you can actually see a little bit more of what I'm seeing in case this view isn't quite visual enough. So I'll bring it back around in a second. So I brought you in for a close-up. Don't know how well this is going to turn out. It looks all right on the viewer, but you know, we'll have to see how this comes together. I figured I would show you just a close-up view of what I'm seeing as I'm running machines. So I've got us lined up on one of the last of the driving studs. Now this might give me some trouble because the last one I did started spinning on me while I was cutting it, and I think this is going to do the same. So let me change out to a smaller. The problem is when this comes down and cuts, it's going to catch on the nut and start spinning. So let me change to a smaller end mill that'll go right down the center of the bolt itself and essentially remove most of the material inside, and then that should allow me to chisel off the nut here. So give me 1 second and we'll change over the end mill here. What I do want to do is readjust my stops here because that's a shorter end mill. So take the stops all the way down. That's going to cut it quite nicely, and then I just want to make sure that I stop myself before I hit the surface of the drum. So we reset on the surface of the drum. Give it a little couple toot tree scoches up just a bit. That'll clear the drum and not hit it and damage the surface, which is what I don't want to do. So now we hold that there, bring this around, make sure we're close to center, sauce it up with a little bit of cutting oil. And engage. And this metal is very soft, so it cuts very nicely. So just going down and plunging a little bit at a time. Allows any of the debris to clear out. Allows the chips to kind of get out of the way. And there we go. Broke it free and clear. So I've got 2 more left to do. We'll bring you around when we wrap this up. There you have it, folks. I've pulled the wheel off of the mill here, cleaned up the last of the chips. There's still a little bit more in here. I'll wash it out off camera. No need to see that. My biggest concern is making sure I get all these chips that accumulated. Those will destroy the bearing races if I leave them in there. So I have an ultrasonic cleaner over on the side of the shop here. That hub is going to go for a nice long soak in there. That'll help to loosen up a lot of the grease and remove some of those chips that have accumulated. But like I said, the drum itself is free. You can see it's loose, and then I'm just wiggling it. Jiggle, jiggle, wiggle, wiggle. Lose the wheel. Come on. And off it comes. So that's a huge success. That was a lot easier. I should have done it that way instead of using the fire the last time, but I had the mill set up for a different project. Now that I can go ahead and now I can just drive this center hub is the press inside here. This is very much the same at this point as it was to take the fronts apart. I won't make you watch me go through all of that again. So let me disassemble this and then we'll wrap things up. Well, there you have it, folks. Once again, I'm a little bit out of breath because it took a little bit more than I expected to pull the wheel apart, but we did it. The last wheel off of Eleanor is apart. I've got some prep work to do, just cleaning these things up and getting them prepped, especially washing that hub out to get all those nasty metal chips out of there. I might even drive the races out and wash them separately. But that's the last wheel. They're ready to go, be taken down to the wheelwright, get them remade, one step closer to getting Eleanor back on the road again. The next major project is going to be getting the 15 parts car kind of cleaned up. I've already got some folks who are asking for parts off of it. You've been in touch with me, or I've been in touch with you. I've got some pictures to take, and I've got to get this moved to its sort of final resting place, if you will, because once I take the front spindle off that I need to fix Eleanor, this car is no longer going to be able to roll. So we'll be working through that as well, as along with all the other projects I've got going on here at the Antique Automotive Acres. So with that, I think we'll wrap it up for the day. If you like the video, feel free to give it a thumbs up. Maybe give my channel a subscription. Go ahead and hit that little bell icon there. That does something with the YouTube Blackmagic Analyticals about giving you an alert when a new video is posted, and at least let you know when I'm out here doing some stuff. If you got any questions or comments, feel free to put them down in the chat window below. If you're looking for parts for your 14 or 15 Studebaker, there's still some stuff on the gray car to my left off camera. You really kind of only see a little bit of it right now that are still available. I'll be stripping some of the other parts off of it right now. I will say the wheels and the windshield stanchions have been spoken for. But if you're looking for something else, maybe we can figure something out. With that, again, like the commenting, the subscribing to the channel, please. If you like this, you can go back and see some of the other videos about some of the other cars here at the Antique Automotive Acres, my 1906 Rio, or get to know Eleanor a little bit better, my 14 Studebaker, the car that I'm currently working on by disassembling these wheels. So with that, I think we're going to wrap it up. I appreciate you stopping by, and thanks so much for watching. Have a good one.